Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Subnetting plays a fundamental role in IPv4 networking because it allows large address blocks to be divided into smaller, more manageable segments. In this episode, we will walk through the entire process of subnetting from the ground up. This isn't just theoretical knowledge. Subnetting allows for practical control over network boundaries, improves traffic management, and isolates devices into logical groups. By breaking down address spaces, organizations can minimize broadcast traffic, better organize infrastructure, and support security objectives such as segmentation and traffic filtering. Understanding how subnetting works is therefore essential for network efficiency and stability. The Network Plus certification places great emphasis on your ability to perform subnetting tasks with accuracy and speed. It is one of the most testable concepts on the exam, appearing in many different formats such as multiple choice questions, diagram interpretation, and calculation-based scenarios. You may be asked to determine the number of hosts a subnet supports, identify valid IP address ranges, or analyze a subnetting plan to check for overlaps and misconfigurations. Whether it's a question that requires raw binary math or one that asks you to infer configuration details, your ability to follow subnetting steps methodically will make the difference between a correct and incorrect answer. The subnetting process always begins with a given network block. This block will include an IP address and a subnet mask. A typical example might be 192.168.10.0 with a subnet mask of 255.255.255.0, which is equivalent to a /24. Your first task is to determine the network address, which is the starting point of the subnet. This network address defines the boundary of a specific subnet and helps identify where the host address space begins and ends. The network address is crucial because all calculations for valid host ranges and broadcast addresses originate from this point. After identifying the starting address, the next step is to convert both the IP address and subnet mask into binary format. While this step might feel tedious, it is necessary for accuracy. Binary notation reveals the exact split between network and host portions, which is vital for calculating how many bits are available for subnetting. For instance, converting a mask of 255.255.255.1092 reveals that the first 26 bits are network bits, and the remaining 6 bits are available for host identification. This visibility helps confirm that subnet boundaries are accurately calculated and ensures that all downstream steps are built on a solid foundation. The next step is to define the new subnet mask by borrowing bits from the host portion of the address. If you start with a /24 and borrow 2 bits, you create a new subnet mask of /26. This means that instead of having 256 total addresses in a /24, you now have 4 separate subnets with 64 addresses each. Writing the mask in CIDR notation, as in /26, not only simplifies documentation, but also aligns with how most modern routers and configurations express subnet masks. This expanded mask allows for finer granularity when organizing networks by size or function. Once the subnet mask has been extended, you need to calculate the number of subnets that have been created. This is done by applying the formula 2 to the power of n, where n is the number of bits borrowed from the host field. For example, borrowing 3 bits gives you 2 to the power of 3, which equals 8 subnets. Each of these subnets will have the same number of addresses, depending on the number of host bits remaining. Calculating this value is essential for network planning, especially when you are allocating address space across departments, buildings, or functional groups. After determining the number of subnets, the next calculation involves identifying how many usable host addresses each subnet will contain. You apply the formula 2 to the power of h minus 2, where h is the number of host bits. The subtraction of 2 accounts for the network and broadcast addresses, which cannot be assigned to devices. For example, if you have 5 host bits, that gives you 2 to the 5th power, which is 32, and subtracting 2 leaves 30 usable host addresses. This number helps ensure that each subnet has enough space to support its devices without wasting addresses. Following host calculations, it's time to determine the full address range for each subnet. This is done by stepping through the network in blocks of a specific size, defined by the number of addresses per subnet. For instance, with a /26, each subnet increments by 64 addresses. Starting at 192.168.10.0, the next subnet begins at 192.168.10.64, then 192.168.10.128, and so on. Calculating these increments is vital for mapping your address space accurately and for avoiding overlaps or wasted blocks. Each subnet has a beginning and end, and identifying the network and broadcast addresses for every subnet is an important part of subnetting. The network address is always the first address in the range and serves as the identifier for the subnet. The broadcast address is the final address in the range and is reserved for sending messages to all devices on that subnet. All addresses between these two are considered valid host addresses. Recognizing these three categories, network, usable hosts, and broadcast, is essential for both assigning addresses and configuring routers. After defining all ranges, the next task is to assign IP addresses to individual devices within the subnet. This can be done statically, where you manually assign each IP, or dynamically using DHCP to automatically distribute addresses from a defined pool. Regardless of method, it's essential to ensure that only usable addresses are assigned and that reserved addresses like the network and broadcast are not given to hosts. Proper address planning also involves ensuring no two devices receive the same IP, and that address allocations align with any existing DHCP scopes or routing configurations. To finalize the process and confirm accuracy, it's best to apply the entire subnetting process to real-world examples. Start with a sample network block and perform every calculation, determine the network address, convert to binary, define the new mask, calculate the number of subnets, compute the host count, step through address ranges, identify reserved addresses, and assign valid IPs. Double-check every step to ensure no overlaps occur and that all ranges are within scope. Practicing these steps repeatedly will help you internalize the logic, identify errors before they affect production systems, and prepare you to handle even the most complex subnetting questions on the Network Plus certification exam. Mastering subnetting requires more than just understanding the theory. It also depends heavily on consistent practice, using reliable techniques that build both speed and accuracy. One of the most effective ways to prepare for subnetting questions on the Network Plus certification exam is to incorporate tools like prefix length tables, decimal to binary charts, and subnet calculators into your study routine. These tools help clarify the structure of IPv4 addresses and make it easier to convert between formats. Over time, repeated exposure to subnetting problems will improve your fluency and help reduce mistakes during timed exams or real-world implementations. Familiarity with certain common prefix lengths is also a valuable shortcut when performing subnetting tasks. Knowing that a /24 provides 256 total addresses, a /26 gives you 64 total addresses, and a /30 offers only 4 total addresses allows you to quickly choose the correct subnet size without redoing all the math. The usable host counts for these prefixes, 250, 4, 62, and 2, respectively, are based on the removal of the network and broadcast addresses from the total. Memorizing these values can save you critical seconds during an exam and reduce the chance of errors. A major goal in subnetting is to avoid overlapping subnets, as overlapping ranges can cause routing conflicts and disrupt communication across the network. To ensure that each subnet is unique and non-conflicting, you must track address allocations carefully. This is typically done using an IP address management spreadsheet or documentation chart that lists each subnet's starting address, ending address, broadcast address, and the range of usable host addresses. Without this kind of tracking, it becomes easy to accidentally assign an IP to multiple devices or segments, leading to difficult-to-diagnose problems. One of the key benefits of subnetting is its ability to segment networks according to logical or organizational needs. For example, subnetting allows you to separate traffic between departments, such as human resources, finance, and development, or between different floors or buildings in a campus environment. Each group can be assigned its own subnet, helping to isolate sensitive data and improve overall performance. This segmentation also lays the foundation for access control, as routers and firewalls can enforce rules between subnets based on policy. Troubleshooting issues caused by incorrect subnetting requires a good understanding of how subnets interact with IP address assignments. Common errors include assigning an IP address that falls outside of a subnet's valid host range, configuring a default gateway that is not within the same subnet as the client, or using mismatched subnet masks that confuse routers and prevent proper packet forwarding. When diagnosing connectivity issues, checking these values is one of the first steps in identifying the root cause of communication failures. Routers rely on accurate subnetting information to make forwarding decisions. Every interface on a router must be configured with a correct IP address and matching subnet mask for the subnet it belongs to. If a subnet is misconfigured, the router may be unable to reach neighboring networks, or it might drop packets altogether. For this reason, subnetting is essential to routing functionality. Network Plus exam questions may ask you to determine whether a routing problem stems from incorrect subnetting, or if a particular route will work given a specific address and mask combination. Different address assignment strategies also affect how subnetting is applied. In static environments, administrators assign fixed IP addresses to devices by manually choosing from within the valid host range. This method requires detailed planning and documentation to avoid duplicates. In dynamic environments that use DHCP, address scopes must be carefully configured to align with the subnet's boundaries. If a DHCP pool extends beyond the actual subnet or overlaps with another range, it can result in address exhaustion or conflicts that prevent devices from obtaining valid network settings. Subnetting shows up frequently on the Network Plus exam, especially in scenarios that require analysis of address blocks or validation of configuration details. You might be asked to identify whether a proposed IP address falls within a given subnet, calculate the number of subnets that can be created from a larger block, or find the broadcast address of a given subnet. Diagrams may include routers, interfaces, and assigned subnets, requiring you to interpret relationships and match addresses to their correct roles in the network. Your ability to solve these problems accurately can significantly impact your final score. One of the most useful preparation methods is practicing with mock subnetting questions that include real-world constraints. For example, you might be given a /24 block and asked to create 6 subnets for various departments, each with its own minimum host requirement. You will need to allocate address ranges from largest to smallest, avoiding overlaps and calculating host totals precisely. These exercises reinforce every subnetting principle, including prefix selection, host range boundaries, and address planning discipline. As you improve, try working without calculators or charts to simulate exam conditions. Calculate address ranges using only the formulas and logic you've learned, and verify your answers by converting between binary and decimal formats. Practice determining the number of usable hosts, stepping through subnet blocks, and identifying the network and broadcast addresses with confidence. Aim for consistent accuracy and increasing speed, as subnetting is one of the few areas where a solid grasp of numerical logic directly correlates to success. Subnetting also provides long-term value beyond the exam. In real-world environments, well-designed subnetting plans make networks easier to scale, monitor, and secure. They form the basis for DHCP scopes, access control lists, routing tables, and firewall configurations. A mistake in subnetting can ripple through all of these areas, while a properly calculated plan can save hours of troubleshooting. Understanding the rules and patterns of subnetting equips you with a framework that supports better network architecture overall. Even in networks that rely heavily on IPv6 or use automatic configuration tools, IPv4 subnetting remains a core skill for many environments. It is used in legacy systems, transitional networks, and hybrid deployments that require backward compatibility. Therefore, being able to calculate subnet ranges, verify host capacities, and apply subnetting logic manually is still expected in many job roles. On the exam and in professional practice, this knowledge remains as relevant today as it was when classless addressing first gained popularity. In conclusion, IPv4 subnetting is more than a math exercise. It's a structured process that requires a deep understanding of network organization and address logic. From calculating prefix lengths and host ranges to verifying address assignments and avoiding overlaps, every step contributes to a reliable and efficient network design. On the Network Plus exam, your ability to navigate these steps with clarity and accuracy will be critical to passing. With sustained practice, you'll not only become fluent in subnetting calculations, but also gain the confidence to apply those skills in real-world network environments. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.